Alright, so let's just comment this out. Yeah, something worked. Okay, it's working, right? So Y and Z as well, and let's just randomize them all. Uh, and tensor um, B equals A and Z. A and Z. Um, right, so yeah, this is our computational graph. And then, alright, so now for these operations, I need to add something. So I've just created an enum over here, which basically is, it's enumeration, which gives names, uh, a clear name to some integer values, right? So it starts from by default it starts from 0, and then it goes to n minus 1, right? However number of operations do you have. So we've created this, and what we are going to do is we're trying to build our own computational graph, right, which has the operations information as well. So right now we have successfully built this graph, but we don't have this operations information available, like from which operation the tensor um, has derived or has been created, right? So let's just say I have tensor add. Let's grab this one, t dot c, and paste it somewhere here. Where's tensor create? Yeah, here. And then I have something called tensor matml. Uh, so add, let's comment this out because we just want to create our testing environment in t.c file. So this is going to be like tensor matml, and just copy this one as well. So I'm just copying these functions to that file, and I'll test them locally first of all. T.c, and if everything works fine, then we'll add them, right? Okay, so this is my tensor c, and comment this thing out as well. Perfect. By the way, if you like my Groovebox dark new theme for my Vim, do let me know because I'm just loving this new theme. Alright, so now we have t.c, we have our tensor matml operation, and we have our tensor add operation. Now we need to assign the operation, the op, something new, right? Something that we have introduced over here, and this is going to be yeah, let's just see what this is basically. So we have yeah, so we have operation type, and we have some constant as name, right? And so tensor add, let's go to here, tensor add, and just do one thing. If required squared equals true, then we have something. Tensor add backward, op op type, and this is going to be or op type would be add, and op name would be add, operation add, right? So these are the two things that we just added in our tensor metadata. Now what does that mean? So I mean, it's very simple. We're just trying to build a computational graph, right? And for our computational graph to work, we need to store the names of the operations, right? So when we will actually visualize this graph, we'll have every node available and we'll have the metadata associated with that node, right? So we can see that which particular operation does that node belongs from, and we'll have basically a way to trace out that what operations are being implemented. So this will happen for only those tensors which are derived tensors, right? And by derived tensors we mean that are created by using some operation, and by operation we mean that those are created by either multiplication, division, exponential value, hidden layers, or whatever, right? So these are the operations. So these were actually the important things that we did. We just added a few new things in our metadata, and this is actually helps visualizing the computational graph, and helps with logs and monitoring, right? So we added these two new things, and same are the things that we need to add in matml operation as well. So let's just test this if this work. Let's say tensor shape 2D a, and tensor get 2D a. Okay, so we're getting the tensor and we're getting this shape as well. And if I want to check now what particular operation is applied, then I can just see it as well. So if I go like printf, and this is going to be integer, I guess, and let's try to do this. So a type, a type, okay, t dot c. So is it type or what? A dot type. No, it's not even op type. Okay. Or can we do something like this? Alright, so a, I think this should be op dot type. A op type. Still not printing. And requires squared equals true. Now if you see this add operation, if required squared equals true, then this thing will happen. Then it will populate everything, right? So now I hope we can print this. So if a operation not null, name, and that would be a name, and this is going to be type. What's wrong here? Alright, so we're getting the name and the type, right? Why the type is null? It should not be null. Tensor add has operation type. Oh man, so this should be an integer, right? Perfect. So we're getting the name and we're getting the type of the operation, right? This is perfect. Uh, so you are understanding that we are able to build our computational graph, right? And things are going well for now. So the metadata is working. And let's say if we have something called a equals this and tensor, let's say b is going to be tensor matmul. It's going to take arena a and z, right? And now a requires squared equals true, we know that. And now let's just say that we have the types for z as well. So sorry, this is b and this is always going to be b, right? And now let's just see if you're able to print this shape 2D, and this is also like shape 2D 4b. Something's wrong, not equals null. Okay, so yeah, null should be null. Yeah, shape mismatch. Obviously we are going to take the transpose, so let's say tensor zt is going to be tensor. Okay, and let's just add, instead of zt over here. Yeah, it's working. Still null, but the type is 0 and 16 cross 16. This is working fine. And if we make a little bit more changes over here in the tensor matmul operation, let's just see if we have populated these parameters or not. So yeah, so op type is going to be what? Mm, this is going to be matmul, I guess. Yeah, matmul, and then op name is going to be times or whatever. Sorry, add op, and yeah, op add or op times or whatever. Op times. Okay. Something is wrong. Perfect. So you see, we have we have built our computational graph on the forward pass, and now we are able to actually assign names to the operations as well as their types as well. So by type we mean that we are just uh, we have an idea that this particular operation is this thing and its name is this thing. So we're just adding metadata in order to in order to keep track when we will backpropagate, right, of every single node. Perfect. So yeah, so things are working, and now we can just replace these with the actual operations, actual functions, right? So this is our tensor matmul. Let's just um, copy this tensor c matmul, and we just come over here and just paste it. Yeah, just paste this right here. T.c tensor add, just copy this one as well. Okay, put it back to the main files. Tensor.c, so tensor add, where exactly is this thing is? Okay, add over here. Alright, perfect. So this is working, and we can push the changes as well. Git commit modified add tensor add and tensor matmul for p names. Autograd. Alright, cool.